Hey, how are you doing? This is Mike again, and we are going to continue on with our rational equation method of solving these guys. We are going to make sure that we have tried some more advanced examples, a little bit different, and they're a little bit different than the ones we did in our prior videos. So as we progress through these, we recognize that we have an equation because we have an equal sign. We have an equation because we have an equal sign, and then we also recognize that our variables in the denominator. So the first thing we should be thinking to ourselves is, what is the domain of this problem? What is the domain of this problem? The domain of this problem. And if we remember that in our domain question, in our domains, we know that we can never have a zero in our denominator. So we recognize here with our first portion of our radical equation, we know w minus 7 cannot equal to 0. Therefore, we're going to add 7 on both sides. So w cannot equal to a value of 7. So that's our first domain issue. And notice we have the same exact denominator over in our second portion, our second term. So the domain of this problem is, w, I always have a issue drawing those, w such that w cannot equal to 7. And if you want to write that in interval notation, some people like interval notation. As you advance through math, you're going to realize that set notation is preferred to interval, but I don't mind showing you both. We're going to start at negative infinity, go until a value of 7, and then we're going to join this with 7 and go on to infinity, and we're not going to include 7, therefore we're going to use a set of parentheses, not going to use a set of brackets. So now we have to identify our least common denominator, which we can get from our two denominators. However, we never want to repeat values, so we never, not want, but we never need to repeat values or terms. So this is terms. So we have w minus 7, so we have a w minus 7, and then we have another w minus 7, but we don't need to repeat it. So all I'm going to do is multiply through by a value of w minus 7. So we're going to have 49 all over w minus 7. That's going to equal to w squared all over w minus 7. And we're going to multiply this through by a value of w minus 7. So when we do that, we're going to multiply this term, we're going to multiply by this term, we're going to multiply by this term and this term, both terms. So in our last example, I showed you there's a little intermediate step which you can continue, but I'm going to keep continuing. I'm going to keep on continuing. Show you this meeting. I'm going to keep on showing you this intermediate step. There we go. So we're going to have 49 times the value of w minus 7, and this is still all over w minus 7. And that's going to equal to w squared times w minus 7 all over w minus 7. So I know my 7 sort of change up. So let me make sure I make these 7s consistent. So this is a 7. Sometimes I put a slash through my 7, sometimes I don't. It was the way I learned it in 3rd grade. So now we recognize that my w minus 7 and my w minus 7 cancel over here, and my w minus 7 and my w minus 7 cancel over here. So we're left with 49 equals to w squared. But remember, when we solve this is a form of a quadratic equation. So remember, we've said if x squared equals to a value of k, and we say k is a constant, we said this in one of our prior videos, this implies that x will be equal to plus or minus square root of k. So we have to add that plus or minus in front of this when we solve. So as we solve our w squared, make sure not to forget this value of plus or minus. So I'm going to take the square root of the right side and take the square root of our left side, but we're going to add plus or minus there in front of it. So now this will imply that plus or minus 7 is equal to a value of w, So remember, we have a domain issue. We always have to refer back to our domain with these rational equations. So we know in our domain that w cannot equal to a value of 7, and we found that w equals 7, so we must eliminate this solution. Therefore, the only solution that we can allow is the solution w equals to negative 7. You can plug that back in and you can verify for yourself, but for now, just to keep this video shorter, we're going to continue on to a slightly more advanced example. So in this example, we have three terms. And then we have a couple more complex denominators. So the first thing that I like to recommend to do is I recommend to factor all denominators. So I think that's important because that way you can see if any terms are repetitive. Sometimes they're not as transparent if they are not factored. So with our first fraction, we're going to have 1 all over 4x plus 12, but hopefully we recognize we can pull out a GCF of 4, which gives us a value of x plus 3. We're going to subtract. 1 stays constant. I always worry about negatives and subtraction signs because I know I'm thinking about distribution later on. X squared minus 9. X squared minus 9 is a difference of two squares, so this falls in the form of x plus 3 times x minus 3. Remember, if we have two squares and we are subtracting them, that gives a plus b times a minus b. One plus the other and then one minus the other. So here we're going to have x plus 3 times x minus 3, and this will be equal to 5 all over x minus 3. That last term we don't have to worry about augmenting because it's completely factored. So now we see we have some terms repeated. We have this x plus 3, which is repeated here, and then we have an x minus 3, which is repeated over here. So let us go ahead and state the domain of this problem. And I'm going to do this a little bit faster. Because hopefully we'll recognize them a little bit easier now. So we know we have 4 times x plus 3 cannot equal to 0. We divide both sides by 4, and that cancels off, and we get x plus 3 cannot equal to 0. Subtracting 3 on both sides, we get x cannot equal to a value of negative 3. So that's the first value that we're going to have to exclude from our domain. We don't have to worry about doing that again because that's the same factor right here. So our last factor we have to evaluate is this x minus 3. So x minus 3 cannot equal to 0. Adding 3 on both sides, and we get x cannot equal to a value of positive 3. So these are our two values that if we get them as solutions, we must exclude. So now, let us go ahead and identify our least common denominator. Our least common denominator is going to be determined by multiplying all of our non-repetitive terms in our denominator. So remember, non-repetitive means that we can't or we shouldn't write repeated terms. So notice here I have a 4. I know that I'm going to have a 4 in my LCD. I have an x plus 3. I'm going to write this x plus 3 in my LCD. Notice I have another x plus 3, but I want to exclude any repeated values, so I'm not going to write that again. And I have an x minus 3, so I have to include that in my least common denominator. And then my last one is also another value of x minus 3. So I recognize that my LCD for this problem is going to be 4 times x plus 3 times x minus 3. I do not recommend multiplying and distributing that out. I do not recommend doing that. I do not think that's important. It actually is going to hurt your ability to solve this problem, so keep it in this form. So now I'm going to have 1 all over 4 times x plus 3, and I'm going to subtract off 1 times x plus 3 times x minus 3, and that's going to equal to 5 all over x minus 3. And now I multiply this through by this LCD. So this LCD will be distributed to this term, and this term. So hopefully we can see in each one of these terms, I'm going to have some terms that cancel. So this 4 would cancel with this 4. This x plus 3 would cancel with this x plus 3. So I'm left with the value of x minus 3 times 1. So x minus 3 times 1 is just a value of x minus 3, and this denominator cancels off. I subtract. Notice here that this x plus 3 cancels with this x plus 3. This x minus 3 cancels with this x minus 3. And all I'd be left with is this value of 4. So I have minus 4. And this will equal to, notice, I have an x minus 3 here. So there's 3. I'll do 4 underlines. That'll cancel with this x minus 3. And we're going to be left with the 4 and this x plus 3. And we will have 5 times 4 times x plus 3. This 5 comes directly down. Then we have the 4 and the x plus 3 from our least common denominator. And now we've eliminated our denominators, and we can go ahead and solve. So we're going to get x minus 3 minus 4 gives us a value of x minus 7. And that's going to equal to 5 times 4, which is 20, still times the quantity of x plus 3. We get x minus 7 equals to 20x plus 60. We distribute our 20 to both of these two terms. And now we're going to simplify and combine similar terms on both sides. So I'm going to add 7 on both sides. And I get x equals to 20x plus 67. And I'm going to subtract 20 on both sides, 20x. And I'm going to subtract 20x on both sides. And I get negative 19x equals to a value of 67. And I divide both sides by negative 19. I divide both sides by negative 19. And I get x equals to a value of negative 67. That's a negative 67 all over 19. And notice I want to verify this against my domain restrictions, and we said that x cannot equal to negative 3 or positive 3. So I feel content that this is a valid solution. And remember, you can always go through and plug it in at the very end just to solidify and make sure that it is correct.